In this section, we're going to cover all of the essential React concepts that you need to know to build amazing apps. We're going to cover all of the most significant React features, including React hooks from front to back. We're going to cover all of the JavaScript that you need and how it helps us build better React code. And we're going to make a small application of our own, a social media app that's going to mirror in many ways the larger app that we build in the course. So the first question is, how do we build a React app? Well, we could make it manually. We could make all the files and folders ourselves. We could install all of the scripts and packages that we need, but it's a lot easier and more sensible to use an established tool that can do so more reliably and faster. We're going to be using a tool called Create React App that's going to allow us to very quickly create a new React project. So to use Create React App, we're going to need to open our command line, to use the command line on our computer. For Mac computers, you can do so with the terminal application, and if you're on a Windows computer, I believe you can use the command prompt. So first we'll want to make sure that we have Node installed correctly on our computer. To ensure that we do, we can run the command node -- version. And here you see that I have version 12.14 on my computer. You want at least version 10 installed. We also want to confirm that we have npm, the package manager that we'll be using, installed appropriately with npm -- version. And we see that I have 6.13. You want to make sure that yours is at least 5.2. When you have npm version 5.2 or higher, you have access to a tool called npx. npx is great because it allows us to use npm packages that we'd normally have to install directly on our computer, allows us to use them without doing so. It saves us a lot of time and space in our computer. So we're going to use npx to grab Create React App to create our React project. But before we do that, before we run this command, I'd recommend that you cd or go into a folder on your computer that you want to add this application to, you want to add your project to. So right now I want to go into my desktop, so the project can be created there. So I want to say cd and go into the folder desktop. And you might have a dedicated folder for all of your React projects. That would be another good place. Now we want to run npx create react app, and then we want to specify the app name. The app name is going to be used for the folder that all of our code and everything is put into. And here I'm going to give our application the name React Social Media. Feel free to call your app whatever you like. And when we run this, npx is going to use Create React App, and it's going to create a folder with the name that we specified. It's going to create all the files that are necessary. We're going to go through those, and it's also going to install all of the dependencies that we need. So once this process finishes up, we can find the folder that our project was created in, and to start working with our code, to start building our project, let's open up our code editor, Visual Studio Code. And we can take our folder and literally drag it into Visual Studio Code in the new window that pops up. And once you do so, you should see all of the files within the project folder right here in our File Explorer. The first folder that you'll see is this Node Modules folder. This is literally every JavaScript package, npm package, that is required and was brought in by Create React App. Now we don't need to be concerned with all of the libraries here. It can seem overwhelming. All the libraries that we need to care about are listed within package.json. So all of those are listed here in dependencies. You can see a few testing libraries here, but really the only dependencies that we care about are React, React DOM, and React scripts. And in fact, you can take a look here at React scripts in the scripts area. These are the different scripts that we can run to do different things within our app. We can start our project with this start script. We can build our project with the build script. We can build it for production with that script. So we don't need to ever touch this Node Modules folder. The next folder here is public. And if you're familiar with how single page applications work, React, just like any other single page app, uses an index.html file that you see here in order to display the app itself. So for anything, any page that a user sees, the index.html file is going to be served to the user, and the page is going to be controlled with all the JavaScript that's provided here within this file. And then the most important folder, the folder that we really need to care about, is this source folder, this src folder, which stands for source or source code, the code that we can make changes to. So it includes all of these files. We don't need to care about all of these files, really. We want to start from scratch. We want to make the most basic React app that we can to see its essential structure. So we can get rid of this. We can right click and hit delete to move it to the trash, and we can use this new folder button right here to create a new source folder, a new src folder, and within it we'll make an index.js file. This is all that's needed in order to make a React app. And I would say the simplest React application consists of the following. Write a div, the text hello React. So it looks like I wrote just simple HTML, but note that I did so within a JavaScript file. What's powerful about React? What's the great benefit of using it? React gives us something called JSX, which is known as JavaScript XML. And JSX allows us to write this HTML syntax to build our application, the appearance of our application, the structure of our application in our JavaScript. So the two are kind of merged together, and it gives a lot of dynamic behavior to HTML that we wouldn't have otherwise. But note, as I mentioned, this isn't HTML, but we can write it exactly as if it was. So since this is JavaScript, we can treat this entire element as an expression, just like if we were writing the number 42. An expression resolves to a value, so we can store this in a variable. We could put this in a variable called greeting. Now, this by itself isn't going to work as our application. We're going to need to use React in order to parse it, to make sense of this JSX, because the browser won't know what to do with it. So we want to use ES modules to import this React dependency. We want to import specifically React from the React dependency. And additionally, as I mentioned, our entire application is going to be served within this index.html file. And we see here within the body, there's only this one div with the ID of root. This is our root node. This is what our entire app is going to be injected in. It's the point that our app is going to be mounted to. So in order to render, to display our application, we need these two pieces. We need this root element, this JSX, and we also need this root node to insert our app into. So we want to import, in this case, the React DOM package. We want to import specifically React DOM from React-DOM. And we're going to use an appropriately named method called the render method. We'll say React DOM.render. And first we'll pass in our app. That's all within our greeting variable. And we also want to create a reference to our root node. And to get access to this, we want to use just plain JavaScript to find, using the DOM, a div with the ID of root. We can do that by saying document.getElementById. We want to get the element with the ID of root. We'll pass that in as the second argument. So once we have all of this, we can save it. We can save index.js, and we can run our project in development. We can develop our project using the start script. So in our terminal, note that there's an integrated terminal within Visual Studio Code. We can find it by going to View and then Terminal. We can also use the command Control and then the tilde key, which is right underneath Escape. Once we open that up, we'll run the command npm start. So React Scripts is going to start our project. It's going to run it on a local development server. It's going to open a browser for us to be able to see the compiled application. And we see finally our app, our div with the text hello React. So this is the basic syntax and structure for any React application that we want to make. It all starts right here. So the fact that we can use this HTML syntax within JavaScript files, this is JavaScript, JSX is JavaScript, we can do a lot of things with it. Since any JSX element is just an expression, not only can we assign it to variables, but we could also do things like display it conditionally. We might have a variable called isReactUser, And that might be set to true. If that was true, is React user is true, then we might want to render our greeting. Otherwise, we might want to render a different greeting. We might want to say, otherwise we'll just assume they're a basic JavaScript user. We might say hello JavaScript. So if is React user is true, see hello React. If it's false, hello JavaScript. It can also be returned from functions. We can have a function here. So let's remove the second render statement and let's create a function maybe called say greeting. And if we have a React user, we might want to return our greeting. Otherwise, we want to return, as we had before, hello, maybe this time hello Python. So now we can execute say greeting here directly within render, and when we save, we see hello Python. So we can already start to see the more dynamic nature of JSX as compared to normal HTML. JSX also allows us to nest expressions within these expressions. So how do we do that? Well, let's go back to our previous example. We just have our greeting. We might have a year variable. Say the year was 2020, the current year. We might want to say hello React in the current year. And the way that we would insert this value, we could nest an expression, is we could wrap year instead of curly braces to be able to execute year as a JavaScript variable and insert it within our text. So now when we save this, we see hello React in 2020. So we can add dynamic values to our JSX. Note that if this was an object, we would get an error. We can't insert objects as a child within our JSX, only primitive values like strings and numbers, etc. But as we saw in the error message, we do have this concept of children. So assuming you're familiar with HTML, we can, of course, nest HTML. We can nest elements, I should say, JSX elements. So within our div, we could have an h1 first, and we could say hello. And underneath that, we could have, in a set of paragraph tags, in a paragraph element, welcome to React. Now, before we save this code, note that in order to have JSX on multiple lines, we need to wrap it in a set of parentheses for this to be valid. So now when we save this, see Prettier automatically formats that for us, and we see first our h1 and then our paragraph element. And if we right click and hit inspect, if we look at the body content itself, if we go into where the app is mounted in the div with the ID of root, we see in fact that we have a div, which is our greeting element, and within it our h1 and a paragraph. So this is created as actual, this corresponds to actual HTML. And again here, the div is the parent element, and the h1 and the paragraph elements are children of the div. We still have this relationship between elements as parents and their children within them. But note that despite all the similarities between JSX and HTML, there are some subtle differences. HTML and JSX have a slightly different syntax. For example, in normal HTML, if we wanted to write an empty div, it would look just like this. But in JSX, we can also write it just as a single tag, like the following. This is also valid. When we do have a single tag element as compared to a two tag element, like a div that has an opening and closing tag, if we have a input, for example, that's normally written like this in normal HTML, we're getting an error here because for every single tag element, it needs to be closed with a /. That removes the error that we see, the squiggly line that we see. So this is just a subtle syntax difference between HTML and JSX. And additionally, one big difference is the fact that if we want to write an attribute on a given element, say we had a button, an opening and closing tag, and the text submit, if we wanted to write an attribute, it's not going to be written in the same way as a normal HTML attribute would. The biggest example of this is the class attribute. We can't write class just like this. We have to write it according to its JavaScript equivalent. Since this is all JavaScript, class is therefore class name. If we have a class, for example, but we don't write it as class name, so we have a class of button and we save, what's going to happen is that we're going to get this warning telling us there's this invalid DOM property class, and it's going to correct us. Whenever we write an attribute incorrectly in the normal HTML syntax and not the JavaScript, that is to say camel case syntax like this, we're going to get that warning. But once we fix it and we hit save, that error is going to go away. And one other large difference when it comes to HTML versus JSX is that we can't write a simple style attribute like this with a set of quotes. Any styles that we want to write have to be within a JavaScript object. So we have a couple of sets of curly braces, and then also any style properties that we want to set on the given element also have to be written in camel case. So for example, if we wanted to set the background color, we wouldn't write it as background-color. Instead it would be background color written in camel case. And we could set it to whatever we want, just as long as its value is a string. If we save that, we see that it works. So be aware of these slight differences between normal HTML and JSX. So we've been able to see a lot of the dynamic nature that JavaScript has given to HTML with this new creation of JSX, but we can take it a step further. Let's think about a basic JavaScript feature that allows us to reuse code as many times as we like, accept some input, some optional input, and return some output. And that would be a JavaScript function. So what React has done is not only has it merged HTML and JavaScript, but it's used the better features of JavaScript to give this new creation of JSX even more power. So let's go back to our original greeting example, where we had a div, or maybe an h1 with the text, Hello React. Now this is great, and we're using it with the help of this greeting variable. It enables us to reuse it wherever we like, but with the help of functions we can create our own custom JSX elements. So instead of having this expression assigned to a variable, we can create a function. And maybe this h1, Hello React, would be within the top of our application. So it might be within a function that we call header. And so now we can take this h1 element and return it from this header function. Now note a subtle difference here in this function versus a regular JavaScript function. Notice that the name here is capitalized. Now we no longer have greeting, but we can use this header. We can use it as a custom JSX element. So instead of calling it like a normal function, we could call it with a set of parentheses just like this, and it would work fine. We save, we take a look at the result, works fine here. But let's write it as if it was an element itself, just like this, with a single tag. We don't need multiple tags here. And when we save this, it's executed just like we were calling it normally. And what's powerful about this feature is that we can compose this new function with any other JSX elements. Say we had a div here and we wanted to put the header up at the top, and we had a footer. So when we save this, we can make our own application of custom elements, and we can reuse this as many times as we like throughout our app. And this very powerful feature that React has given to us is what's known as a component. This specifically, since it's made with a function, is a function component. Now, we're using this in the function declaration syntax with the function keyword, but we could also make this as an arrow function. We could say const header is equal to an arrow function, and that would be equally valid. Now, we're going to be using function components a great deal, almost exclusively, but I want you to be aware of one older variant of a component called a class component. Now, classes are JavaScript functions. So be aware that this isn't a different data type, but we could make the same exact thing, the same exact component by saying class header extends React.component. Then we'd need to use this method called render and then say return h1 with the text hello React. And that also works. So returning to our function example, we can get rid of our class component. We know that functions accept an input. Let's go back to our function declaration syntax. We know that functions accept an input. Obviously it's returning an output here. It's returning JSX, but we can make this even more dynamic by passing in whatever values that we like. So what if we wanted to change the name that was displayed here? We're saying hello React, but instead we wanted to replace that with a user, some username within our app. Well, if it was a normal function, we would have to say header and call it like a normal function. Note that this wouldn't work just like this. We'd have to interpolate it, meaning insert it between these curly braces in order to get the return value, so this evaluates to an expression. We would need to pass in some value here that would serve as the username. So we'd need to maybe pass in the value John or whatever value we wanted to use. And if this was a normal function, let's just say it was lowercase header, we would accept the argument and we'd name that username, and then we could interpolate that. We can insert that within our JSX. That would be returned. And that works, but it's a bit different, a bit better, as you'll soon see, with function components. So let's change this back to a function component, and instead of just having an argument that we pass like this, remember that we're using it like a JSX element. How do we pass it with this syntax? How do we pass a value to our function component with this syntax? Well, we use what's known as a prop. So just as we received in our header function this username value, we create a prop called username on header, and we set it to whatever value we like. Previously we had John, so it'd look just like this. It's kind of like we're giving this argument a name right here, as compared to giving a parameter a name. Now what do we get for the function component? Well, we don't get individual parameters. All of the prop values, and we can have multiple props here, all of the prop values are received on an object called props. All of our props come right here. And that means the username prop is available as a property of the props object. So we can say hello props.username, and that's it. Now when we save, we get the same result. So if we pass in the username of Dave, see that's provided, or Jane, that works too. So we can think of these as kind of custom attributes, so to speak. These aren't available on normal JSX elements. They're only available on these custom elements, these components. And what's a very important feature of this props object, one rule that we must follow is that we cannot directly mutate or directly change what values we receive here from props. So we can't change in our function component the value as it's being received. We have to accept it as it is or do nothing with it. So we couldn't, for example, receive username, it's being set to Jane. We couldn't receive that prop from props.username and immediately change it to something else. We couldn't change that to John. We can only read from props. If this were to happen, we'd get this big error. It's a read-only property. We'll see later on how we can change prop values that come in using state as well as some other features. So props are read-only. Make sure to not mutate the props object. And one question you might be asking is whether we can, instead of accepting values like strings or numbers as props, whether we can pass in entire elements or other components as props. And in fact, we can. So note that right now we're using header just with a single tag. But what if we expanded this to an opening and closing tag? Well, now we can accept a new type of prop called a child. This can accept children, which makes sense. We covered how JSX elements have the same relative relationships of parent and child, just like HTML tags, HTML elements. So this header component can accept a child prop. Now this isn't particularly useful in the case of the header, but how children is used most of the time, the children prop is used most of the time, is with layouts. So if we have, say, multiple pages in our application, but we want to give them the same layout, say we want to give them the same background, we could create a dedicated layouts component. So we can make a layout, and we could have it return a div, and for that div, we can give it maybe a background of pale goldenrod. So to apply this layout to every page, we could first replace the parent div that we have here for our app with layout. And now all of these are accessible on its children prop. So we can use the props object here in layout, and we can pass its children. We can insert its children right here between a set of curly braces with props.children. Now normally I said between a set of curly braces objects aren't valid. Well, here they are with this special prop. So now once we save, we can see the styles are applied. And we saw earlier at the beginning how we could conditionally return JSX elements, where we could include an if statement and say if something was the case, if something was true, return one JSX element, otherwise we want to return something else. But what about when we want to conditionally display one or another component directly within our component tree, within our hierarchy of components? Say, for example, we have authentication within our app. So we're keeping track of that. We're keeping track of whether our user's authenticated with this variable. Say is authenticated. We'll say that's true. So if the user's authenticated, we show a header with their name. So fine. But otherwise, we want to show, or let's say, a completely different component, say a login component, that tells the user to log in. So we'll return some text that says, please log in. How do we conditionally display the header for the authenticated state or the login component for the unauthenticated state when this is false? Well, we can use a type of conditional that resolves to an expression. So instead of having an if statement, we want to use a ternary expression, which resolves to a value. So to write that, to check for this condition, if is authenticated is true, we can say is authenticated question mark. If that's true, then we show the header. Otherwise, and to write this else condition, we can use a colon. Else, we want to display the login component. So to test this out, if is authenticated is true, we see our header with our user's name. And if is authenticated is false, we show the text, please log in. Now what if, when the user's authenticated, we also want to show a sign out button? And if the user's unauthenticated, we want to show nothing. We don't want to show that button. So how do we have a conditional where if something's true, we show it, and if it's false, we don't show anything? Well, instead of a ternary expression, we can use what's known as a short-circuiting operation with the double and operator. And the way that this works is that if a condition's true, then it moves on to the next expression and returns it. And if it's false, false is returned and nothing is displayed. So we can once again interpolate this expression. We can check to see if is authenticated is true. We include our double and operator, and let's create a sign out component where it's just going to return a button that says sign out. So if is authenticated is true, we want to show that sign out button. Otherwise, nothing. So when we're authenticated, we see the button. When we're not, nothing. Now, there's a bit of an improvement that we can make here. Maybe you can spot it. Notice that when we have our user authenticated when it is authenticated is true, we're showing two components, but we have two separate conditionals. What we can do is we can include sign out within this ternary. We want to return both of these components. So we can comment this out. And by the way, to comment out JSX, you can hit the command and / keys. You can see I'm toggling it here. Every comment needs to be wrapped in a set of curly braces. So here we want to return, in the true condition, in the then condition, we want to return both header and the sign out component. So we'll put this on multiple lines. We need to put this on multiple lines. So we'll wrap it in a set of parentheses and we'll add sign out here directly underneath. So when we save this, we see that we get this parsing error. Adjacent JSX elements must be wrapped in an enclosing tag. Did you want a JSX fragment? So this is a rule of working with JSX. Just like we need a single element as the most parent element, is the root element for our application, we also need a parent element, surrounding element, for any JSX that we're trying to insert in our component tree. So we could, of course, wrap this in a div, and this would work. But notice that we're adding an unnecessary element to our component tree. We're adding this additional div right here. In order to avoid that, there's a special React component that was created called a fragment. This is ideal for displaying multiple components namely in conditions like this, but it's useful in other cases too, where we just don't need an HTML element. So the longer syntax for writing this is to say react.fragment. It's an opening and a closing tag, just like that. So that works, but we can also use a very convenient shorthand syntax that looks just like this. It's very concise, and when we save, it does exactly the same thing, and we don't get that additional element anymore surrounding this. This is ideal for when we don't want to apply any extra styles to our elements that might change the orientation or the position of our elements. So our code's starting to get a little bit complicated here. So what we can do is we can create a dedicated app component. We can drag all of this code. We can highlight all this code and drag it, pull and drag all of it into app itself. And of course, wrap it in a set of parentheses and then replace and render all of our components with just app. And make sure to write it as an element. And we'll bring root node all the way down here. And in fact, let's reset a little bit. Let's remove all of this. And let's go back to our previous example. We'll remove all of these elements that we added. Let's go back to just having an individual person, and we'll put them in a variable. Put them in a variable called person. We had Jane previously, and we just want to put her name within a simple paragraph. We'll remove the header. So naturally we see Jane within our app. But what if we wanted to deal with a list of people? What if instead of just a single element, we had an array of people? Say we had John, Dave, and Jane. How do we display them all? How do we display them in individual elements, individual paragraphs? The best way to convert arrays of data, like we have here, into a list of elements is with the help of the map method. And this is very similar to the built-in array method map that we'd use in plain JavaScript, where we could say people.map. But what map allows us to do is allows us to get access to each element. And most times when we use the map method, we use it in combination with an arrow function. So basically this is saying, well, we can get each person and then we can return them. We can do with them what we want. And in this case, we want to return them within a JSX element, within a paragraph and we can return all that. So when we save this, we get our list of people all within paragraphs. Simple enough. And again, since this resolves to a value, that is a list of elements, we know what to do if we had any surrounding elements. If we had, say, an unordered list that we wanted to put all this into, put the return value into, and maybe we had LIs that we were returning, well, all we have to do is just wrap this in a set of curly braces. And now we have an unordered list with a number of list elements. And note that map can be used for components as well. So say we had a person component, a very simple one, where it did basically the same thing, where we want the same output. We're going to accept each name and return it within an LI. Well, first of all, we could return for each person a person component, and we would pass down person their name as a prop called person. Then we could receive that in our person component and our props object. Then we would return our li as before and get the person prop value from props.person. Pretty straightforward, but if we look at the console, we see a warning. Each child in the list should have a unique key prop. So what's a key prop? Well, key is a special prop that React needs. We don't need to use it. React needs, if we ever wanted to, say, delete an element, delete one of these persons, or we wanted to update them, React needs to know which person we're talking about, which list item we're talking about, and it references that and knows how to update the DOM performantly with the help of the special key prop. Key prop. So we need to provide a unique value here, a unique identifier. And ideally, this is going to be an ID, a totally unique string or number. This is essential for when we're trying to update an element or remove it. But since we don't have an array of objects here, where say each object has a name, property, as well as an ID, consists of some unique string, since we're in a pinch and we don't need to make any changes to this list, or we aren't currently, we can use from map an additional parameter here called the index. We can get that as the second parameter. We usually label that I, and we just need to add a second set of parentheses in order to get it. So we can set key to I. So when we save this, our warning goes away. Now let's say we want to do something with these people. We want to be able to detect when someone clicks on each person. And the way that we do that is with the help of events in React. I really should say event handlers. These are attributes of elements, JSX normal elements, that we can make use of to detect when a user does something. So we're going to go over the two most common types of events in React. The first one being a click event, and the way that we detect that is with onClick. So for each li, we add the attribute onClick. Again, it has to be used in this camel case syntax. We can't write it like it was HTML with onClick being all lowercase. That's invalid. And we need to do something, execute some function when this element's clicked. So here within our function component, our person function component, let's create a function called handle person click. And what's this going to do? Well, it's just going to display the person's name whenever we click on them. So we'll pass a reference to the function handle person click to our onClick event handler, and we want to display that person's name when they're clicked. So to do that, we can maybe either alert or console log props.person. So now when we save and we click on Dave, we see an alert that says Dave. Note that this is the most common convention for writing an event handler function. It's going to be prefixed with handle. We want to handle a certain event. Now note that here we actually get access to event data. So in addition to alerting the person's name, we might want to console log some of that data so we can see what we get. When we click on this, we see in our console a bunch of stuff coming from this event object. So the event that's passed from onClick to our function is an object which includes a bunch of information. This isn't exactly like a normal JavaScript event. This is technically called a synthetic event, and includes a lot of React-specific stuff. But it's going to be very familiar to you if you're coming from plain JavaScript. And generally speaking, we don't really need it for click events. Where events are most useful are with inputs and forms. So say we had an input here within our app, and we wanted to be able to detect what a user typed in. The other most popular event handler is the onChange event handler. So when there's a change event, which fires whenever a user types into an input, we're going to get an event for that. So we'll connect onChange to a function with an app called handle input change. And naturally we want to get, when the event's passed to handle input change, we want to get the text that's been typed in. So again, we'll provide event as a parameter, and we can get the input text from event.target.value. And we'll put that in a variable called input value. We can console log that. So now when a user types into this input, we can see and keep track of all of the keys that were pressed, all of the text that was typed. So again, onClick and onChange are the two event handlers that you'll use the most in creating React apps, but there are many more that we'll cover as we start to build the app in this section, as well as our final project app in later sections.